In this lesson, we'll be discussing what a discrete random variable is and the probability distribution of a discrete random variable. Now, a discrete random variable is a variable which has discrete values, meaning that there are clear steps between the values it can take. So it has clear steps between the values, meaning that the values that can take can be 0, 1, 2, 3, and so on, but there will be no in between values like 0.11, 0.12, 0.13. Random will mean that the value it can take, it depends on chance. So the value of the variable depends on chance. Now the probability distribution of a discrete random variable is basically all the values a variable can take and their corresponding probabilities. So for example, let's say we have a discrete random variable. As an example, we can take the roll of a die. Now, let's say X is the value that we get on a die. So we know that when we roll a die, there are six possibilities: 1, 2, 3, 4, 5, and 6. Now, the probability of each of these values is 1 upon 6. So we can just write 1 upon 6 with each of these numbers. And this is called the probability distribution table of a discrete random variable. Now, let's take a look at another example where we have to make the probability distribution for a discrete random variable. Now, in this question, it says a fair square spinner with sides labeled 1, 2, 3, and 4 is spun twice. The two scores obtained are added together to give the total x. We have to draw the probability distribution table for x. Now, we know that it can take values 1, 2, 3, 4, and it is spun twice. So for the first spin, it can take values 1, 2, 3, or 4. And for the second spin, it can again take values 1, 2, 3, and 4. Now, the possible values of x can be, so if it gets 1 and 1, the sum will be 2. For 2 and will be 3, 4, 5. And we can just put in all the values over here. As the two scores obtained are being added together, so we are just adding the two numbers on both the spins. So this will be 5, 6. This will be 4, 5, 6, 7. And this will be 5, 6, 7, 8. So now all of these values are the values that x can take. Now to make the table, we can write x and probability of x. So x can take the value 2, 3, 4, 5, 6, 7, and 8. Now we know that there are total 16 possibilities. Out of that, 2 is occurring once, so the probability will be 1 out of 16. 3 is occurring twice, so that will become 2 out of 16. 4 is occurring thrice, so that will be 3 out of 16. 5 is 1, 2, 3, and 4 times, so that will be 4 out of 16. 6 is occurring 1, 2, 3 times again, so that will be 3 upon 16. This will be 7 will be 2 upon 16, and 8 will be 1 upon 16. So this is the probability distribution for x. Now, one thing we'll have to be careful about is that the total probability can never exceed 1. So we can just add up the numerators as the denominators are same, and they must add up to 16. So 1 plus 2 is 3, 3 plus 3 is 6, 10, and then 3 plus 2 plus 1 is 6, which means that the total probability will be 1. So the total probability will always add up to 1.